This is factoring trinomials. So this is actually a little bit of an introduction for Algebra 1 type material that will be useful for you to be able to use in high school. So getting you a little bit of a head start to jump on that. So last week we worked with binomials and we multiplied the binomials together, and what we ended up creating most of the times when we multiply two binomials together is a trinomial. And so the trinomial, again, the prefix tri means three, nomial is names or some kind of identification of a term, and so this is trinomials has three terms in it. So when we're factoring a trinomial, we're going to start with something that typically has three terms in it, and then factor that into its factors. And so remembering what a factor is, well, this first definition is for the word factor. So a factor in math are terms or expressions that can be multiplied together to obtain a product. In other words, they are the numbers that multiply to make other numbers, right? So factors of 12 are 4 and 3, 6 and 2, because those numbers can multiply together to make the number 12, right? So that's factors of them. When we are doing a process in math that we call factoring, factoring is where we're going to write something as a product of its factors. So like my example with 12, if I were to be factoring 12, I would be writing 6 times 2 and 4 times 3 and 12 times 1. And that's doing a factorization or factoring of 12. So I'm writing it as a list of its factors. And so that's what we're going to be trying to do with our polynomials, or in this case, our trinomials, again, which have three terms, right? So the standard form for a trinomial, standard form just means what does it look like when it's just kind of all variables. Well, there's going to be an x squared term that's part of the trinomial. We noticed we were getting that quite often when we were multiplying binomials last week. We put an a in front of that as it's just kind of its coefficient, so just to give it an identification. The x term goes next, and it's going to have b in front of it as a coefficient. And then we should be left with just a constant, which we'll call c. So ax squared plus bx plus c is our standard form for what a trinomial looks like. Standard form decreases in exponent power from left to right. So notice the x squared term is going to go first, then the x term, and then just the constant with no variable at all. So if we had other terms like a cube or something to the fourth, to the fifth, it would typically go in front or to the left here of the x squared term to be in standard form. And if a term is not present, so if it happens to not be there, like the x squared term's not there, the x term's not there, or the constant's not there, then that means that their a, b, or c value would then be 0. Okay, remember, if they're there, so if it's just x or if it's just x squared, that means that it has a coefficient of 1, so it means that there is 1 there. So identifying the a, b, and c in the following polynomials. So this polynomial is a trinomial again, to start off with here for number 1. So 3x squared minus 7x plus 12. So the a is always found as the coefficient of the x squared, and so in this case that would be 3. The b value is the coefficient of the x term. In this case, it's 7, but there's that minus in front of it, so it'll be negative 7. And then the constant, or the c term, is 12. So what we're going to find is that this is going to be necessary for being able to identify our a, b, and c's from our trinomials in order to be able to factor them properly. For number 2, we've got 5x minus 13 equals negative 4x squared. So this isn't in standard form because it's not written with the x squared term first, but the a value is not always necessarily the first term, it's the coefficient of the x squared. So in this case that would be negative 4. For b, it's the coefficient of the x term, that would be positive 5. And my constant in this one is negative 13. For number 3, we have x squared plus 3. So we only have two terms in this. This is technically a binomial then. But if we think of it in terms of a trinomial, again, that means we're missing the x term. So since we're missing the x term, that means that b holds a certain value then. So in this case, x squared is there, no number in front of it. But remember, if it's there, that means that there is 1 present, right? So we put that invisible 1 in there. And so the a value here is 1. The b value, since there is no x term, since it's not there at all, that's where the 0 is going to come into play. And then we do have a constant, and that's 3. Number 4, 15 plus 3x. Again, another binomial here. And so a is going to be equal to, well, since there's no x squared term, this time my a value is 0. My b value is in front of the x, which is going to be 3. And I have a constant, it's 15. Okay, so that's going to come into play when we do what we're going to do next, which is factoring our polynomials. In this case, our trinomials are the ones that we're going to focus on for this, but it's possible that you might be missing the b term, so it might not have necessarily three terms in it. So that's why I use the term polynomial here, which just means that it has more than one term. So our first step is going to be identifying a, b, and c, just like we just practiced. So we need to identify what a, b, and c are. We're then going to set up a diamond problem. So this is why I had you practice diamond problems yesterday, because next step is to create the diamond problem, where in the top of the diamond problem, we're going to put a times c. So whatever we identify as a times c, we are going to put that at the top of our diamond problem. And b, whatever the b value is going to go on the bottom of the diamond problem. So that's kind of helpful to remember. B on the bottom. A times C on the top, B on the bottom. Okay. Then we're going to find the factors that complete the diamond problem. So in that case, that'll be the left and right side that we need to get. And then we're going to use the factors as the constants in the binomials that make up our answer. So what we're going to be doing is we're going to be starting with a trinomial, and we're going to be factoring it into 2. So we'll have one trinomial, and after we factor it, we're going to make 2 binomials. Okay, so kind of in general, here's what it looks like. So if we start off with a trinomial that's ax squared plus bx plus c, the first thing I'm going to do is identify what a, b, and c are. Okay, so I'm going to identify the numbers for a, b, and c, and I'm going to list out what those are. That's step 1. Step 2 is set up that diamond problem. So I'm going to make an X like this. You don't have to necessarily make it a full diamond, so just like the worksheet you were practicing with yesterday, just an X is going to set it up. But this is kind of the standard look for the diamond problem. Again, what we do is we take the a and the c value, multiply those together for the top. So a times c there, and then b goes on the bottom. So we put our b term down there. Now the tutorial video I had you watch yesterday, they did x and y as their 2 numbers for the sides. Since we're going to use x a lot of times in our equations, or that'll be the variable that's found in our trinomials and binomials here, typically what you're going to see in most math texts is that we're going to call these m and n here now. Okay, so these are the factors that we're going to have to find. Now remember, to complete a diamond problem, these 2 numbers have to multiply together to make the top. They have to add together to make the bottom. So we're going to have to do a little bit of thinking about what numbers complete the diamond problem properly there. But then once we do that, then what we do is we take the variable that was in our trinomial, which in this case was x as the variable here, not our coefficients, but our variable was x. And we're going to add m to the first one and add n to the second one. So whatever our factors were that we got from our diamond, they're going to end up going as the constants in our binomial factors. Okay? So again, identify a, b, and c. So what's a, b, and c from our trinomial? Multiply a times c to make the top. Our b value, whatever it is, just goes on the bottom of the diamond. Figure out what numbers complete the diamond, and then use those as the constants that go into the binomials. Now, if we wanted to check our work to see if it was correct, what we could do is we could use FOIL then on our binomial, and we could FOIL it out and make sure that it gives us that trinomial that we started with. Okay, so let's look at actually using that in the examples here. The column questions there, again, I will fill those in and have those on the completed copies of the notes. Okay, now For the most part, for the ones that we're going to look at, that I'm going to have you practice with in this, again, we're just kind of scratching the surface of this whole concept as kind of a preparation for Algebra 1. We're going to look at mostly ones that have an A value of 1. And so when you multiply A times C to get the top of your diamond, it's almost always just going to be whatever the C term is, since the A value will likely be 1. I will go over a few examples down below where the A value is not 1, and how we would approach those ones. Okay, so factoring the following polynomials. So we've got x squared plus 8x plus 7. So first thing I'm going to do is identify A, B, and C. So in this case, A, since there is no number in front of the x squared, it's really a 1 then, so A is 1. The B value is 8, and the C value is 7. I then turn that into a diamond problem, where I do A times C on the top, so 1 times 7, which is just going to be 7 on the top. On the bottom, the B value is 8. And so now I have to think about it. What two numbers can I multiply together to make 7, and then also add to make 8? A lot of times, these are the ones that throw people off because you forget about 1 and the number being a factor of the top product. So in this case, my numbers are going to be 7 and 1 that fill this in, because 7 times 1 makes 7, and 7 plus 1 makes 8, and so that completes my diamond problem. So now what I do is I turn that into a pair of binomials, where my variable from the trinomial was x, and so that's going to be at the beginning of each of these. And then I use one of my factors that I got to be the constant in one of my binomials, and the other one goes in the other. So in this case, plus 7 and plus 1. Now, since they were both positive, that's why they're both plus here. We will end up with some negatives, we'll see. And if it's a negative factor that you ended up using here, then you'll do minus instead of plus. Okay? But this is my answer then. So I've factored my trinomial into a pair of two binomials. Okay. Next week we'll get into why that's important and why that helps us with being able to solve when this is set up as an equation. Okay, number 2. Again, start by identifying A, B, and C. So my A value again is 1 because I had no coefficient in front of the x squared. My B value here is negative 5, and my C value is 4. So set up my diamond. A times C goes on the top, but again A was 1, so really it's just 4 times 1, so that would be 4. My B value goes on the bottom, so that's negative 5. And now I have to think what multiplies to make 4 and adds to make negative 5. Well, the only things that multiply to make 4 are 4 and 1 and 2 and 2. Since 2 and 2 isn't ever going to make 5, it must be 4 and 1 then for my numbers here. But 4 and 1 does multiply to make positive 4, but 4 and 1 don't add to make negative 5. In order to get them to add to make negative 5, but still make a positive 4 on top, I've got to make both of them negative here, right? So negative 4 times negative 1 makes positive 4, and negative 4 plus negative 1 does make negative 5. Now, write that as a product of my two factors, binomial factors. Again, x was my variable in my trinomial, so I will use x at the beginning of each. And then since it was negative 4, I do minus 4, and negative 1, I do minus 1. And there are my binomial factors. Now again, if I wanted to double check my work, I could use FOIL to multiply this back out. The x times the x would make the x squared. I'd have x times negative 1 for my outer, that would be negative 1x, and negative 4 times x for my inner, that would be negative 4x there. And so negative 1x and negative 4x is going to make that negative 5x, and negative 4 times the negative 1 makes my positive 4. So it indeed does FOIL back out to give me the trinomial I started with. Okay, number 3. Again, identify A, B, and C. A is 1, B is 4, C is negative 12. Make my diamond. A times C on the top, that's going to be negative 12. B on the bottom, that's going to be 4. And then I have to think what multiplies to make negative 4, multiplies to make negative 12, and then adds to make 4. Well, factors of 12, that would be 4 and 3, 12 and 1, 6 and 2, and if I think about it, well, 6 and 2 is how I can make 4, So let me put those in there. But notice that the top product, the A times C term, is a negative here. So I have to multiply a positive times a negative in order to end up with a negative. But I want to add to make positive 4. So in order to add to make positive 4, my negative in this case would have to be the 2. Okay, so now I know my M and N that make my diamond, my left and right side. Those become my constants down here. This time the variable was N that was used in the trinomial, so I do N at the beginning of each. I need an N plus 6, and I need an N minus 2. Okay, and then one more here, A, B, and C, but you already might be noticing that we're missing one of the terms, right? This is only a binomial, so it's just a y squared minus 36. The y squared term, since this is the squared term, that means that A is in front of it. In this case, that would be a 1. We're missing just the y term, though, the y to the first term, or just the y term, and so that means the b value here is 0. We do have our constant, though. That's negative 36. Okay, so don't be in the habit of just the first one is A, the second one is B, and the last one is C. It does matter that they are with the proper ordered term. So the squared term should always have the A in front of it. The term to the first power, like in the other three we did, is the B, and then the C is always the constant. Okay, but that just means that negative 36 times 1, so negative 36 on the top. My B value here is 0. So now what I need to multiply two numbers to make negative 36, and then add them together to make 0. Well, if you think about adding to make 0, the only way you can do that is if you have two opposite numbers, right? They have to be the same absolute value, so basically same number, just one positive and one negative. And so 36, as we know, to make that, we can use 6 and negative 6. And that'll make negative 36 when we multiply them. When I add them, it'll make my 0. Okay, so y was my variable that was used in in this case, binomial. So I use the y's there, and then one is going to be y plus 6, the other one is going to be y minus 6. And there's my trinomial, or excuse me, my binomial factors. Okay, so column question over there that you could answer real quick. I'll put it in the completed section of the notes. Okay, and then it says factoring out a term first. I'm not going to give you too many examples, so I'm just going to go over maybe one or two of these just to show how you would approach these. I'm really going to have us focus more on the ones that we went over where the a value is already equal to 1. But it says that so far we've looked at examples of polynomials where the a values are equal to 1. If a does not equal 1, we have to check to see if a, b, and c have a common factor that can be divided out of the terms first, and then factor the remaining polynomial that we are left with. So what I'm looking at in this one is I have an a value of 2, a b value of 6, and a c value of negative 108. If I were to try to do the diamond on this and set it up that way, what I'm going to find is that it's not going to complete correctly, and I'm not going to end up with the proper factors. So the diamond only really works if the a value is equal to 1, or there's a more advanced version of the diamond, which we call X-box, or the diamond box version, that when you're in Algebra 1, you'll go into and figure out how to complete that. Okay, but what I can do is I can get my a value back to 1 if I factor out, or basically divide out is what it means to factor out, a common factor. In this case, 2, 6, and 108, since they're all even numbers, they can all be divided by 2. So if I do that, what I'm really doing is it's like reverse distributive property. I'm dividing out and I'm pulling out, or what we call factoring, right? This is another form of factoring, is I'm breaking this into a set of factors. I could have 2 times, and then instead of n or 2n squared, it would just be 1n squared, plus 6n divided by 2 is going to leave me with 3n there, minus 108 divided by 2 will give me 54. Okay, so now I've got it so that it's just 2 times all of this. So now what I'm going to do is I'm going to factor this using the same technique I just did. So now I'm going to identify my a, b, and c from what's inside. So a is 1, b is 3, and negative 54. Set up my diamond now. So negative 54 goes on top. My b value that's on the bottom is 3. And now thinking about numbers that multiply to make 54, well, I know 9 and 6 does that, and I can also make a 3 out of 9 and 6. So 9 and 6. I need to make one of them negative so that I end up with a negative number on top. And when I multiply them and when I add them together, they make a positive. And since they add to make a positive, that means the smaller of my two numbers, which is 6, is going to be the negative, because that way when I add positive 9 and negative 6, it's going to make positive 3 there. Okay, so that means that my binomial factors here, n was the variable that was used, so I'm going to use n's there. One's going to be plus 9, and the other one's going to be minus 6. But in order for this to multiply to make what I originally started with, I have to now bring into play this first factor that I started, which was this 2 that I factored out. So I put that 2 out in front, so I basically just drop it into the front there of things. Because remember, what we just factored using the diamond was just the things that were inside the parentheses here. And so I also had this 2 that was the original factor of my entire thing here. So really it's 2 times all of this. Okay. So I'll put these ones, the copies of those, in the completed copy of the notes. But again, we're going to focus more on the ones where it's already a is equal to 1 there. Okay, same thing with the conclusions. Conclusion questions. This one, number 1 here, is kind of a good one for helping to figure out the m and n values. And then the parking lot problem here is kind of an interesting one that goes with this. But again, I will include that in the completed copy of the notes if you want to attempt that on your own and check the answers later. So the summary, though, real quick. So the steps that we used to factor this. So step 1. Identify, there we go. So identify A, B, and C. Okay, assuming that it already has an A value of 1. But A is equal to 1 here, B is 7, C is negative 18. Okay, step 2, set up diamond. Problem. So remember, it's A times C on the top. And on the bottom is B. So negative 18 then is my A times C for the top. 7. Okay, and then 3. Step 3. Complete diamond with factors. That's my m and my n values. And so here I'm looking for multiplying to make negative 18, adding to make 7, so 18 and 1, 6 and 3, but that's not going to make 7. 9 and 2, though, will combine to make a 7. So I've got 9 and 2 that'll work, and in this case I want to make a positive 7, so my lesser value, the 2, is going to be the negative. And then step 4, finally, is write my binomial factors using m and n values from diamond. Okay, so x was the variable used here, so x plus 9 for one of them and x minus 2 for the other. Okay, and there's my factorization of that trinomial. Okay, so there's a worksheet for practice problems on this. We also have the Google Meet happening today, so tune into that if it's confusing for you and you need a little help getting some more examples explained, or I can explain it maybe in another way for you. All right, good luck with things.